I'm going to explain how to download the latest 1 million blocks from the Ethereum network, sorry, etherscan.io, from the Ethereum network, and then from the block logs, which I guess you can find somewhere in the transactions, we want to extract all of the mint events of NFTs. So this is like an event, and there are mint events. So I guess this is like a mint. Yeah, this looks like a mint. So basically a mint is specified with the from parameter to be the 0 address. And so that's what we want to do today. And we want to use Neume. Now, I want to do this on as much of a fresh install as possible, but I have already set up something. So basically we have this AX101 from Hetzner that is costing a lot of money, but we are running Aragon on top of it. Aragon is basically a very performant Geth node, and it allows you to run like a JSON RPC daemon and an Aragon node. So I can actually I can log into that. That is the domain of my old project, and then you will be able to see that Aragon is running and that the RPC daemon is running. And then additionally, we also have a consensus layer running that is called, oh, I'm misspelling it here, but I think it's either Prism or Prism with a Y. Yeah, so that's running as well. I already have a like Neume set up in the core repository, but let me move that into like a backup. And so let's really like install this freshly for now, and also like completely reconfigure it so that basically whoever is watching this video can see it. I'm going to increase a little bit of the font. I hope that's enough so that people can see. So we have downloaded the Neume core, and now basically we need to set this thing up. So there's an environment file that's at env copy, and that's already kind of like an example of how that could look like. Now I already know that I'm going to use the Aragon node on localhost, so that's going to be the localhost. Then I think, if I'm not mistaken, I need to understand the port number for the RPC daemon, and ideally find that, I guess, in my own configuration. So I have it here on my machine, and I have it as an SSH script, and so that's the private API. But actually, I think what I need is the a port that starts with 8. Yes, this one that starts with, that is like that's the, I think, the standard Ethereum RPC port. So that's the port in Neume that we are using to basically access the full node. Then we don't need an RPC API key. We need to define a data directory, and in this case it's basically creating a data directory in the core directory. We can probably add the concurrency to like 50, and this is the concurrency with which we're making requests. And then we have a free IPFS gateway defined here, but we won't need it later, and we also won't need, I think, an Airweave repository either. So now we're gonna move this env file into our real configuration, and then we also need to install dependencies. So we'll do that as well. And then Neume actually installs a submodule called strategies, and it also installs dependencies for that. And I think that's basically it. Now, essentially what we have in the crawl path, which is the configuration file to control the entire crawler, we we have an already pre-existing definition of the different kind of like strategies that we want to execute. The strategies can be found in the strategies repository. And basically we have like strategies for all sorts of stuff, like getting catalog, tokenize, or noise, or sound protocol. But what we really need is we need to execute the call block logs extractor function, right? Where basically we would be downloading all of the block logs from like these things basically from each block and so on. So that's why essentially I'm gonna clear out most of the configuration here, and I'm gonna rename this to call block logs, and we'll only need an extractor actually. And then the arguments we can look them up in the actual init definition. And so we need to define a start block and an end block. Now I said we want to do like we want to essentially do like 1 million, right? So this is our starting block. Sorry, this is our end block, which is today's current block. And then this shall be our starting block, right? That's probably like 1 million. So should be like 6 zeros. Yes. Okay. So, and I think like that's kind of like the first step, right? So let me actually execute that for a second, just to show you, also to make you understand that this works. But first of all, there's kind of like a thing I need to do first, which is edit the config, because essentially we are also allowing you to, for example, set rate limits and other things. And so for now, we have set a rate limit on the RPC HTTP host, because usually people define this as Infura, and Infura has pretty like strictly enforced rate limits. So we want to remove this because we are running it on our own Aragon node, right? And because we don't have rate limits. So now there's a couple of options of how to start this, but I think we can start it like in the most conventional way, which is just using the npm script, and we would be using npm run dev. And so that's what we're doing. And I'm already getting an error here because essentially the basically the HTTP value here is not tolerated by our schema definition. Now this is a bit annoying, and actually, I mean, we are an open source project, so sometimes things don't work like how we want them to work. So I will now just make that edit quickly, just to demonstrate, first of all, that sometimes in open source projects you have to get a bit dirty to make things work. But also, I mean, essentially we should just fix that, I guess, in the main branches, but I sadly haven't gotten around to do that yet. So anyways, if I run the npm run dev now, you can see that nothing is really happening for now. And I'm also wondering why that is. It could be that it's still, okay, so it started to work. So basically what is happening now is that this process is essentially requesting data from Aragon's RPC endpoint. And so if we stop that process and we look into our directory folder, then we can see that there has now been a new folder being created called data. And I want to remind you back to the moment when we defined data as the data dir here. And so if we cd into that data dir, now what you can see, and I encourage you to open that with less because it can potentially be quite big, this file, that we have already downloaded 140 megabytes from the Aragon node, and in a file called block logs extraction. And so you can see that essentially, I guess if we were to take one of these and formatted them in a nice way, which now I'm gonna attempt, even though I'm not exactly sure where this one would end. Ah, yeah, here. So if we search for JSON validation online, and we would be pasting this. Oops. Ah, okay. So accidentally we've actually found two. So let's just use one. So that you can see that this is essentially a block, like an event log, right? So there's an address, there's the different topics. I think there can be up to 4. There's the input data to the call, the block number, which by the way should translate to one of the first block numbers that we defined, transaction hash and so on. So I think we are actually, so this is already working, right? So essentially we are getting events, and now one thing that we are not doing yet though is we need to essentially filter these events down by NFTs. And then additionally we want to have all mint transactions. So the first uh, the first topic actually needs to be the like basically an empty byte string. So just to visualize this also, um, if we go into the ERC standards and we find 721, you can see, yeah. So the first topic will be the from argument. The second one will be the to argument, and the third the token ID. Now we can also create a we can create the signature of this transfer event by using KCAC 256, where essentially we are removing all of the metadata from the type definition, as well as also I think removing spaces is important. And then also we need to remove the event keyword as well. And then this ends up being the signature for, oh no, probably this ends up being this, and also this also needs to be removed. So this ends up being the event signature that we are filtering the block logs for. And if we, I guess if we grab the file, and now I'm not super good with grab actually, so I'm just gonna live Google that grab file for string. So if we do that, we should be able to okay, it's actually quite simple. We should be able to find this value. Now I'm not sure if this is not gonna automatically translate into yeah, okay, so it works. So yeah, you can see actually we have this quite a lot. And I mean, if we had to grab this now by ourselves, I think it would be a lot of work, right? And would probably not be so nice. So Neume, it does not only implement strategies that are purely for the extraction of data, but also for transformation of data. So we have basically we've implemented a transformer strategy that is already capable of um, essentially um, filtering out by the event. And actually, I mean, this should be our event, yeah. So it is, and by the empty first topic. So yeah, the first topic is being filtered out, and then also the logs topic are being filtered out. Now, as I said, I think it's important to understand that we are really a kind of like a project where you have to work somehow with the code. And so, look, I mean, in this case, for example, there is also an expectation that we enter a list of contracts, and then basically the logs address is included in this list of contracts, which I think, while it is useful in this implementation of the strategy, it's not necessarily useful, I think, for what we're trying to achieve today. So I'm just gonna go into the strategies repositories transformer, and I'm going to remove that line. So essentially we want to remove everything that has to do with contracts. So the parameter here, then this line here. Then we also, I guess, want to actually, I mean, we can remove this entire mapping operation too. So to end up just getting basically all of the mint operations. And now, before running this like on a larger scale, I think it might make sense to just run it on the small file that we ended up generating. And for that, instead of adding an extractor here, we can add a transformer that has a similar like call structure as the extractor where, and I'm sorry for like this like weird formatting issues here, where basically the first argument always needs to be the input file that we want to transform. And in this case, if you remember, the input file is basically at is basically in the data directory, right? And then it's called block logs extraction. So it's this file. So there's a there's a neat little trick how we can get this path relatively, and it's using resolve and the environment where we have the data tier, and then we just write basically the called block logs extraction file. We close the resolve, we close the arguments, and then we have removed the contracts, and this argument will be filled in by the Neume process, the line argument. So this is gonna go through each line as we have seen with trail so far, and basically it's gonna parse the line and it's gonna filter the logs. So let's actually try and use that with npm run dev and see where this is going. So I think it was fine. I don't see any error messages. And then if we look into the data directory, indeed, we have a new file called call block logs transformation, right? And then if we look into the first topic, just for this one, we can see that this seems to be the right call signature, if I'm not mistaken. Let me actually check that again. So yeah, that seems to be all right. And then basically the first argument of the first element of the topics is always the 0 address. So we have successfully filtered by minting transactions, but we have not done, first of all, I think, so we have only done it for a fraction of the blocks, because if you remember, then I stopped this process. And then additionally, it's also not super useful yet, because I think probably it would be more useful is if we had an NFT, and we would also, oh, I never gotten that actually. And if we would also if we would call wow, I'm so surprised that this is happening now. Anyways, it would be better if we would also be able to call the token URI like this function token URI, right? Where you pass in the token ID, and then it returns basically a string token URI, right? And then usually this points to like the NFT's metadata. So okay, I think we should be doing like two things. One is we really want to download this like 1 million blocks in a serious manner, and then we want to transform them. So let's actually delete everything that we've crawled so far again. Let's look at the crawl path. Okay, so we have to uncomment this again. And I think this is anyways a good setup already for getting all of this. Now, I think another thing we want to do though is that we want to put this task into the background. And so how to do that? I mean, there's probably people are going to tell you different things, and I mean, I'm not maybe I don't even have like the best idea here, but I'm just gonna copy the npm script, the raw script. I'm also gonna add a line that is debug everything into the end file, and then I'm gonna use nohub, and again, like you could use also tmux. I'm gonna use nohub. This is basically my process, this is my crawl path, this is my config file. And then, I mean, internally, this will log into this data repository. But then I also want to basically put the task into, first of all, I want to log all of the logs into a file. So I have this logs file here. But then additionally, I also want to put the task into background, and this with this ampersand. So if I now launch it, it should run in the background. And then with tail minus f, I can also look essentially into the task itself, and I can see that there are some leftover lifecycle messages, and yeah, indeed, it seems to be running now. Now I can also look into top, and I can see that so these things are taking memory and whatever, or I can also look into htop, and I can see what is happening. So there is like, even though this node is pretty big, I think there is some CPUs are being used, although not like it doesn't look like we are like fully using the power of this machine. But anyways, the script is now running. Oh, we got a memory issue. Yeah, this is one of those things where probably we need to do some more edits, and let me try to figure out where is the problem. Apparently I'm keeping it very real here. I think the problem for this issue, and yeah, I realize that this might deter some people from actually using this, but I think it has to do with how JSON schemas are being used right now in the strategy. So I'm going to remove the logs. I'm going to clear the data repository again, and I'm going to relaunch this process now. And let's actually monitor it. Oops. Let's actually monitor it for a second to understand that this is not necessarily happening again. So as you can see, we have already downloaded 2000 blocks here, and we are going fast, and this is with a concurrency of 50. Now again, I don't know about the memory issue here. I think probably have a memory leak somewhere in the strategies repository of this strategy, and we should fix it. But at least for now, it's looking okay, if I'm not mistaken. I think maybe another thing we need to tweak is actually that this is still pretty slow on the concurrency side, and that we are not using the machine enough, I think. So another thing that probably we need to do is like, yeah, just like tweak this a little bit. So let me quickly kill these processes and also verify. So basically this is now down. I'm also gonna remove the logs directory again, and I'm gonna increase the concurrency here tenfold. And I'm essentially just gonna restart the entire thing. I'm gonna look into the logs again, and I'm just gonna, I guess we are just gonna judge based on how fast the logs are scrolling. So yeah, you can see I think this is going faster now, considering that before I think we were like when we looked into the file, we were at 4,000. Now we're already at 2,000 in just a matter of a few moments. So I will let this run, and I will go ahead and basically look into like another thing, just to also look into the htop related stuff. Yeah, there's still not that much utilization of the machine, but definitely a bit more. And probably also on the IO top. I don't have it installed, but yeah. Yeah, and so far it seems to be working. Probably, actually, one thing I would like to try is potentially even increasing the concurrency here. So the concurrency is basically the amount of concurrency that the queue is doing when it's executing tasks, right? So it's basically the amount of um, concurrent connections that we're opening with Aragon. And yeah, potentially, I mean, we can just like try to get into like unstable territory here and see if things are still working out or not. So, I mean, this might as well fail. And I potentially have not deleted the data file, so I better do that before. So remove the data directory, remove the logs file. Okay, I think now we should be fine in starting it. And if we look into the logs, so yeah, I mean, essentially, Neume has a bit of like configuration overhead in that regard that, um, yeah, we have like this thing going where you have to somehow tweak the config. I don't know if it's extremely significantly more faster now than before. I I can't really tell, but we are not getting any errors, so I think we are okay. This is not becoming unstable, I think. And I would also expect actually to have now already a memory issue in case we would be doing things in a wrong way. So I think I'm just for now assuming that all of this is now fine. And I'm simply gonna let this run. I think looking at top, you can see that again we have processes, and then for each top, yeah. Now I think we are definitely using the machine, and I guess there's like quite some like processes basically that we are using, right? But at the same, so let's just run that. And I mean, I don't, maybe I'm not gonna let it run the entire time because I really don't know how long it takes, and it would make a video quite boring, I think. But as a next task, we want to get basically from the mint transaction that we had, we essentially want to get the token URI, and maybe the EtherScan website now allows me to access this NFT page. Yes, it does. And so essentially what you can see here, this is just a random NFT contract that I've now picked. And if we go to the contract page and we look for an existing mint, I guess I wanna demonstrate essentially what the token URI method does. So this is our token URI, and we have interacted with this contract. So if we're doing a read transaction on the token URI function, then we are getting back a IPFS hash. And now wouldn't it be nice if we would get all token URIs for the last 1 million minted um, um, NFTs. So just checking. So yeah, so that's I think that's kind of the second thing that we want to do here. And for that we also have a strategy already, like a generic one. And this strategy is called call token URI. And so essentially in the call token URI, what we are doing is we're first parsing the event log itself. So um, we're looking at essentially at topic 3, which is the token URI, and we're converting it from hex to decimal. We're taking in the block number to access it at a certain point in time, even though we could also be using latest. We're using the address of the log, then we're using something called a signature, um, which is not really in this file, but it's essentially the function signature of the token URI function. And we're also using the transaction hash, although I think this really is more like a metadata thing and doesn't really contribute to the entire if call. I think the if call essentially is this portion where we use the from, the address, and the data. And then we are writing these things to disk. And what we're getting as an output is actually a hex encoded, the hex encoded value of the um, the hex encoded value of the token URI. And so we have to actually decode this by telling the code that this is actually a string parameter. So yeah, let's see if this is still running. Yeah, I don't think we'll get to like 1 million blocks, and but we can definitely at least extract some events, I assume. So to configure that in the crawl path, basically we are adding subsequent strategy, and this subsequent strategy uh, is called token URI, and so let's just go by the definition here. And essentially, in the extractor, we need to pass a source file path. So yeah, this is again like this weird formatting issue. So here are our arguments, and then essentially our file that we want to resolve is the transformer file, and it's called call blocks transformation, right? But then it's asking for additional information, and for that we actually have to look into how the signature is being built in the Web3 ETH ABI, and specifically we have to look at encoding a function call, or I guess more specifically encoding a function signature, and we have to use essentially something like this structure here. Yeah, I'm kind of like doubting if I'm doing this in the right way, but I think I'm still doing it in the correct way. So essentially let's paste in paste in this, but maybe we set paste to paste here, so it's properly formatted. And then essentially the name of the function is token URI. It's a function, and then essentially the first input is a uint 256, and the name of it is token ID. And as far as I understand, we don't need to define the return value here, so we can just essentially remove the second argument, close the list here, and that's essentially our signature, although it's not super well formatted, I guess. And then for our last parameter, we want a filter function. But I don't really see the necessity to filter anything at this point. So I think we might as well just pass in basically an empty operation. So we could be passing in, no, I think probably we want to pass in something like element equals element. Element makes element, right? And I think with this, essentially we should be able to run a call token URI extraction. I already see that here is a spelling mistake, so transformation. And then, I mean, for the sake of this video, even though, I mean, we have not crawled all 1 million, but 70,000, which is also not that bad, I guess. Although it's also not super fast in this moment, and I don't exactly know why. But I think it's fine to kill the process, and essentially we now have the source files here, right? So we have to call blocklooks extraction. It's 14 gigabytes, and in the crawl path, let's disable actually the extractor stage for now. And so now it's just gonna transform, and then it's gonna do the call token URI. So in the same manner as before, we can again start the crawler, and I think we got an error because this element function is an unexpected identifier, and so we might have made a mistake, and indeed we have made a mistake where the crawl path file cannot be specified like this. Now I believe we have fixed that now, and if we look into the logs, basically it should now, and this might also take a while because it's a 14 gigabyte file, but it should now filter and create this file for all of the mint operations. And yeah, it already basically started the transformer strategy for called blocklooks. And so if we look into the data directory, we can see that there's already a file being created. And if we can also tail into this file, and we can see that it's essentially filtering out all of the mint operations from these block logs. And then basically these are, yeah, grouped by blocks essentially for now. Oh, what have I done now? I think might be where the process finished, potentially. So actually let me verify this because I'm a bit skeptical of this. So the latest block number here is 0xe3b and so on. And then the latest block number here, this roughly looks the same. Decimal, back to decimal. So that's like basically almost 15,000, 15 million and that too. So I think this, just to make sure here, I think so this really represents all of the mint transactions. So actually, still I think in the crawl path it should have continued with this function. So I'm currently wondering why it has not continued with that. So let's look into the logs, and yeah, we can basically see that apparently for some logs, essentially the topic 3 is not defined. Now, I don't fully understand why this is the case. I think it's because log is, there may be cases where log is not defined. That's news to me, but what we can do is we can look into the extractor file, and also we can just potentially, I guess, solve that. So topic, so this is here, right? The topic 3, where basically the lock wasn't defined. And I think this is because actually we have changed the structure of the extractor file, right? If you remember, where we removed a bunch of like stuff. So I think here we cannot expect something to be pattern matched with lock. So I think it's probably like this, where we just basically we get the lock and that's it. So let's rerun our file, but we don't need this is the great part I think about Neume, where maybe other parts here have not been that impressive or whatever. I think what is great is that basically Neume has like this pipeline approach towards crawling data. So you can really, I think the idea here is really to work almost in a way like how I work with it, where you basically you're like step by step starting to produce this, because I mean essentially, you know, the thing is like you don't need to go back to this one anymore, right? You don't need to go back to this one anymore. So you're essentially like it's almost like staging in Git, where you end up having something that works, and so you're moving on to the next thing. So this is exactly what we're doing here. So now the baseline is called block logs transformation. We want to call token URI. So let's try that by using this nohub command here, and it's exiting immediately. And yeah, we end up getting the same problem. So maybe we can also look into a bigger look into this. So yeah, so apparently topic 3 is not defined. Now the question is, I mean, if I look into called block logs transformation, there's 1, 2, 3. So I guess starting with index 0, 0, 1, 2, 3, right? Now the question is there ones where this is not the case? And maybe then we should also filter those out. Or we're just generally doing something wrong that I'm currently not aware of. So we could also try to remove the the um, the filter function here. And then I'm also a bit confused by this like NFT line, even though I mean, I guess that's from here. But let me also no. I don't know. We'll just run it again and see what happens. So yeah, it exited again. Slightly annoying. Yeah. So apparently there is cases in there uh, where log topics is apparently is undefined. So I'm just gonna try to make this debuggable now. And I'm gonna check what the value of logs and topics is here. I mean, I guess if just topic 3 wouldn't exist, then now we would at least see something. And yeah, indeed. So apparently there's this very interesting, because there seems to be fields where the third topic is not present. So I'm doubtful that this is then an NFT that we want. And so actually then the filter function might come in handy actually. So so let's add it back actually. So filter, I think it's called filter fn, no, filter func, right? And then in the crawl path itself, basically, so how does this work? I guess if in the element the length of the topic, is it topic or topics? Topics. So topics that length needs to be 4, right? So essentially I'm back and found I found kind of a solution here. Now the problem was that call token URI really spends a lot of time on reading the transformation file. And so just to show that in the code, and I have some debug messages here. Basically this reading like a 1 GB file is still pretty slow for us somehow. And so just like running basically through this operation took a lot of time. But I essentially, just to demonstrate basically now, just to demonstrate the case, what I did in the crawl path is basically I made the span of blocks that were crawling just 2. So it's just 2 here. And then we're running this entire thing until we get the token URI. And so now if we're running this with npm run dev, you can see that it fairly quickly finishes. You can also see that in the data directory we now have 3 files. So we still have the call block logs extraction, which contains all of this data. We also have the transformation file, and then additionally we have the call token URI file, and that's new because essentially it contains this result hex that is essentially the token URI that we were speaking about before. So I think in a final step to also wrap this up now, it would be nice if we could then if we could then transform this file with the call token URI transformation strategy. And for that, I'm going to look into the transformation strategy. And the only thing that we need to be careful of here is basically passing in the result key. So the key from the object, essentially. So in our case, we look into it, then the result key is just called results. No, actually, it's taking from the results. So here's taking from the results, but then it's storing in the result key. So in the crawl path, let me just copy the transformer, and we're gonna use the results from call token URI extraction, and then as a key, the key shall be the token URI. And then, I mean, I guess we could like run all of this again, but for the sake of saving CPU cycles, let's not do that and instead show the staged version of this. So if I call dev now, it says it's already done. So if we look into the data repository, yes, we can see that it created a transformation file. And then indeed you can see that now we are starting to have all the token URIs. So just for verification, I mean we can just go to a IPFS gateway and paste in this. Yeah, and we can see that there is indeed an NFT behind this, and we can get the image as well. And I have no idea what we're gonna see here now, but and it's also apparently loading not super fast on this gateway. So what other gateways can I use? I don't remember right now, but yeah, I mean essentially you can see it working. Look, there's also like just plain Pinata gateways here as well, and then the image also links on Pinata. I don't know why there's no so yeah, the image is also retrieving, and it's some kind of like weird fox red gang. It's a red. Okay. Yeah. So essentially now we would be having like all of these token URIs, and if I would have used like an actual like big file, this would have taken arguably much longer. I think yeah, you saw that, and you know, like the interesting part now as a follow-up would be where uh, we are not only calling the token URI, but then we are also downloading it. So for example, we have strategies to get IPFS URIs, and then essentially we can also implement strategies to get like all sorts of for all sorts of platforms. We have integrated this for the entire music ecosystem, and you can see that a more complex data path then looks like that. Now, as I said, I think a lot of the work here has been like kind of like in the weeds, so you have to edit some of these files yourself, but I think this is in the realm of possibility if you know JavaScript. And I guess at this point, yeah, it's more of like a pro tool than anything else, but we are trying to keep the code base as simple as possible and as accessible to anyone as possible. So I think, yeah, this should always be possible, hopefully. And that's why I think this tool can be useful for people that want to download data from Ethereum. So yeah, I don't know how long this recording has become now, but probably pretty long. And so for anyone that has made it so far, thank you. And yeah, see you in the next one, I guess.